Greetings to all. My name is Paul John, and this is my sixth. This is my ninth year record in the computer networks lab, and this is all about IPv6 routing. In the previous videos, that is the last 8 videos, we have seen IPv4 routing, not routing. I mean, IP address. Now, the problem with IPv4 is that, as you know, it's like 32 bits. So, as the number of networks increased, or the users that use the networks increased, the number of hosts and as well as like the credibility of IPv4 decreased. Its efficiency decreased. So that's the reason we started using methods like subnetting and all that. But even that is proving to be incapable of supporting the vast and highly developing necessity or requirement of networks and IP address. So, a new generation of IP address, that's IPv6, which is claimed to be able to provide IP address to each and everything of the world, including each and every sand particle. That's what the claim. And the claim is actually true because the IPv6 is supported based on a 128 bit system, and as that sounds, it is a very huge number, and so it is represented using hextens. It's not normal decimal binary values. As you can see, this is the method of representing a IPv6 address. I'll read it out. It's like 2001. Then instead of dot, it is used a colon to separate the hextens. These each unit is called as hextens, and and then even though we use the hexadecimal format, still the address is a bit too much complicated. Hence, there are two rules that are used to compress the address, and the rule used are, the first one is that all zeros, all preceding zeros, that is, for example, if it's like if the address is something like instead of this 2001 db8, if it's like 001 db8, that the first three zeros can be removed, and can be written as 1 db8. And also, as you can see, this double colon, this happens when that hexent is 0. That's if there are 4 zeros, and in such a case, like only for once, for one set of 0 hexent, you can remove that and write as a double colon, but it can only be done once in the hexent. If there are 2 zeros, you can't remove both of them, only one. That's the basic way. That's the basic theory on this. Now let's move on to stimulation I've created to show how the IPv6 configuration can be done. And this is my packet trace or stimulation. As you can see, there are 3 routers, as well as like 3 routers with 3 switches and one PC each. And as you can see, the IPv6 address given for the first PC is 2001 db8 1 2 and a double colon F and /64. Now, similarly, I've given for each of the PCs. Now let's move on to the router. I've already given the necessary commands to show the configuration of the router. As you can see, first I've used show IP route. Here IP route won't work because it's IPv4. IP route is for IPv4. So we have to use a command called IPv6 show route. I've done that over here. IPv6 routing table. As you can see, the IPv6 routing table has been shown. Now then, there's another command which is IPv6 interface briefs, which as the name suggests, it shows the interface configuration of the router. And here the 0/0 interface is connected with the network. With this is the address given, as well as the serial 0/30. It's connected with this one, and 3/1 0/3/4 3/1 that's connected to this, and that's it. Now for the running config, as you see in the running config, it's clearly shown that the IPv6 addresses, and also it can be visible that the IPv6 route. This is the static routing that I've done with the for each network, and that's it. That's about it. Now let's just try and pinging. Let's go for a new scenario. I'll go with the stimulation mode. Let's try with PC1 to PC0, and here we go. I've been successfully, as you can see, I've successfully been able to ping the packets. So my stimulation worked, and hence my IPv6 configuration is spot on. And that's about it. Thank you all for watching. Hope to see you guys soon. And thank you guys for all your support. And if there is any rectification I can do to my videos, uh, please do contact me. My details have been specified in my channel, and please do subscribe. And this is Paul signing off. Wishing you guys, I don't know, bye.